I'd like to welcome again everyone. I hope most of the people came in, but of course the door always open. So this session will be a little bit different because we will have a keynote speech first, just to raise the topic, raise some issues relevant with technology development. And for this, we invited a Hungarian company, namely Contact Electro from Pécs. And they are really an interesting company because apart from they have the marketable products they're producing, they have heavily invested in hydrogen technology in the past 10, 15 or 20 years. I can't even count, but we can say for decades. And starting from fuel cell to, and I won't say any more details about it, but many other kind of applications you will see. And if someone, then they can tell all the problems that they have faced, which will be very interesting as a starting point of the following panel section. So I would like to pass the word to Tibor Sirbik, manager of hydrogen technology development at Contact Electro. Please welcome him.
Thank you very much. First of all, I would like to thank for the opportunity to make this presentation now. And as it has been said that I would like to focus on the technical challenges nowadays hydrogen system integrators are faced with. But before that, just really a short introduction who we are and what we did until now. But I will jump through these slides because we have no enough time, and maybe the focus should be the discussion about issues and challenges. So from 2007 here we are working on this area. It is really a long time period, but in the meantime we did many pilot projects step by step, really starting from the basement. For example, we made our own fuel cells together with MTA and Budapest University. Even we knew that this project will not have outcome as a market, as a product which can be placed on the market. It was rather about learning. Also, it was the thing with hydrolyzing system. We made our first very low power generators, 1 kilowatt, 5 kilowatt, and 15 kilowatts, and mainly all those was because of learning, and we learned a lot. And at the beginning, we started to work on a really wide range of products, because hydrogen technology covers really a huge area. But after a few years, we concentrate on these four parts. Municipal vehicle manufacturing. As a matter of fact, at the moment we have a running project of making two garbage collector trucks, one four-wheeler 90 ton and one six-wheeler 26 tons. This project will be ended until the finish of next year. Marine application, as you see, for that we also have finished project, 6.5 meter long boats capable to carry 9 persons, and the max velocity is 22 km per hour. Hydrogen powered generator replacing diesel generators are also in our focus. We made some, we are also making some with 60 kilowatts at the moment. The fourth part is decentralized energy modules for local micro-regional energy supplies. So there will be a pilot project near Page. I will not explain it in details, but mainly we will have solar panels, hydrolyzers, hydrogen storages, and depending on the circumstances, we will be able to charge electrical vehicles or even hydrogen-powered vehicles, and also we can connect it to the grid. This is the plan, but we are working also on that. That is just an explanation what I was talking about. We have no time, we have John. Now we are approaching the main task of my presentation, the technical challenges. As it can be seen that if we have a fuel cell by itself, it covers less than half of the cost of the whole system, and it can be seen that the reason is that many other components should be fine-tuned to have a stably work hydrogen-powered system. First of all, gas supply. Now, a few years ago, it was a real problem to get good capacity vessels. Now I can say that vessels itself can be found on the market. There is no problem. But at the moment, when you need to make some bunches from that, we will face with a problem, because even now the manufacturers of vessels are telling mainly that there is a lack of human power, so the delivery time of these plants are really long. Oh, yes, it is a biggest headache for fuel cell integrators. Cooling system. So, at the first sight, it seems that no problem, because if we compare, for example, 100 kilowatt combustion engine powered system and 100 kilowatt fuel cell powered system, we can say the efficiency of fuel cell is up to 55%. For combustion engine, it is less or equal than 40. So, no problem. The cooling system which is used for combustion systems can be used. Even maybe we can make some downgrading. It is only on first sight. unfortunately, it is contrary. There are two main reasons for that. First of all, in case of combustion engines, at least 20% of waste heat will go through exhausting system. And in case of fuel cells, we still have also their exhaust system, but it is not comparable the heat going through that system with the combustion engine exhaust system. That is one thing. The other thing, which is even more important, is that on combustion systems, on combustion engine systems, you have a cooling liquid 100 degrees centigrade, and that should be passed to the environment. In case of fuel cell systems, you should not exceed 65 degrees centigrade, because otherwise the fuel cell itself will be damaged. Meaning the delta is much less. So somehow you have to handle this problem. In the case of stationary systems, you can provide higher radiator area, and it will somehow solve the problem. Even when we are talking about hydrogen-powered boats, river or sea boats, it's still not the problem, because we can use the nearly unlimited heat capacity of sea or river. The problem, the real problem, starts when we are talking about road vehicles, because there, in many cases, you will not have enough room to make this bigger area radiators. Okay, still you can go to the way that you can use compact radiators, but those requires much higher air pressure and air flow rate, meaning in many cases more than 10% of produced electrical energy by a fuel cell should be wasted to drive the ventilators, so the blowers. And normally, what I was talking about, there's as a rule of thumb, for every 1 kilowatt cell, 50 kilowatt cooling circuit must be provided to cover also the peaks. Let's stay in cooling system theme. There is another big problem with cooling system for fuel cells. The fuel cells itself need a really low conductivity of the cooling fluid, because otherwise it will be, as cooling fuel fluid goes through all cells, it will make a short circuit, so the fuel cell control unit will shut down everything. Meaning that you can use only special and mainly very expensive materials to build the cooling system, which will go through the fuel cell, meaning aluminium, some kind of stainless steel, but just some kind, and some special plastic materials. For that reason, when we are integrating those systems, we use two separate cooling systems. Auxiliary, which will cool all the power electronics, engine, diodes, and so on, where it is not a problem, so we can use normal materials. And just fuel cell cooling will be built by this special and expensive material. Another problem is, not just challenge, safety system. Hydrogen is very flammable and danger. So many, even in laboratory, we have 3-level security. So redundance times 3. So and also in vehicles, you should have concentration sensors, automatic shutoffs, even automatic ventilation system, which will start when the concentration is elevated. Another problem that the range of voltage and or current of our DC-DC converters or inverters needed for fuel cells is not matching the range of commonly used equipments for solar system, even for pure electric vehicles, because pure electric cars has many parts which are compatible with fuel cell systems, but still we have this, let's say, bridge between DC bus and fuel cell itself. And there is a real energy flow, meaning the high energy. So it means that you have very few manufacturers, at the moment at least, who are dealing with this range of power and voltage and current. So they are very expensive. That is one thing. But the delivery time is very long. But yes, I know that if this market will grow, some other manufacturer will start to have those kind of products in portfolio. In that case, it will disappear, this problem. I'm sorry, my time is out.
You can still take a minute or so.
Okay, so here just some results from our company. That is about what I was talking about. It is a 15 kilowatt fuel cell, and as you see, it can run up to 6 hours. It is just a layout. Maybe it is more interesting, as it is a very low power system. The whole system is very simple compared with some today projects. So you have here no, okay. You have here a stack. For cooling, that's what I was talking about. It is really simple because you have a primary loop which goes through stack. There is a heat exchanger, and the secondary loop goes through river itself. So it is very simple in that case. The produced electricity from a stack or fuel cell can charge the battery pack, or through controller directly drive the engine. And as I told, it is a really simple system. What I was talking about, that just for learning purposes, we already made an experimental hydraulic filling station. It is also in working condition. Our intention is not to use it on daily basis, but we also learn a lot until we somehow succeed to finish it. Another thing which we was not talking about, the supercapacitor. In many cases, even for power generators 50 kilowatts, we are not using rechargeable batteries at all. We are using for startup, just that. And all the buffer function is provided by supercapacitors, and maybe in few years we will be able to use them also in these vehicles, because at the moment the same problem what I was talking about, that there is no DC-DC converter on the market which can cover the needed current and voltage, because the main advantage of using ultracapacitors is that they had nearly unlimited current sunking capacity, meaning that if there is a real peak during braking, as a recuperation it will be ideal, and these ultracapacitors will be capable by themselves to suck all the charge which at that moment appears there, but the voltage conversion should be done by DC-DC converters, which cannot be reached at the moment of the market. But when it will be, also we will use it for vehicles. Again, some pilot project, mainly for our learning. It is also working. Emergency power supply. It is finished project which is already working on the on daily basis. So we solved that. And what I was talking about at the moment, our main project is making those two hydrogen-powered garbage collector tracks. And that will be that. Thank you very much.
Thank you. So, if I haven't mentioned already, for us at the university, maybe Contact Electro was the first Hungarian company that we heard, but it was years ago, And we heard that they're dealing with, as you could see, from hydrogen fuel cells to applications. So it was really interesting for us to know this information, and we immediately visited them as we could to see how they developed this. And congratulations on all the achievements you have done so far. I think it was a boost, at least for university in Pécs for sure, and I think it was a boost for Hungary as well, that you invested in this technology so early, and you're there where you are right now. And so this is a Hungarian perspective. We could also see from the previous session that underground storage, megawatt scale electrolyzers, and fueling stations, these are already being investigated or are already done on a research level. But in this next session, we will see what else do we have on the international scale. So we invited guests either from foreign countries, or some of the guests are from Hungary with an international outlook because of their position. So I would just call them namely, and later on we will open this session. So I call them in the order of sitting. So let's start with Christian Kuhn, who is the leader of Vehicle Technology Research Group here at the university. Then welcome Jur Iming, the Business Development Manager at Resato High Pressure Technology. Please welcome Professor Han-Kwon Lim, who is the Director of Carbon Neutrality Demonstration and Research Center at UNIST, Ulsan City, South Korea. And I forgot to mention Yuri is from Netherlands. And last but not least, please welcome Achilles Habencius, Engineering Director at Ganzer Compression Technologies. So, our attention with the presentation on contact electrical was to raise questions, and we definitely got some. And you can see that with this type of new technologies, you always have challenges. And I'm sure that everyone can imagine that how many challenges there were with the first combustion engine vehicles as well. So these are manageable things, and we are studying, I mean, that's true for those people that engineers are studying to solve these problems. So society might not should be so afraid of these challenges. These will be solved. So believe me, I'm an engineer, as the saying says. But anyway, let's start with the domestic and the international outlook from the perspective of our speakers. How do you see the sustainable energy as a whole? Not only hydrogen, but of course, please reflect on hydrogen technology as well. So how do you see the sustainable energy state of the art in your region, and how do you see it internationally? So let's stay at the order of the plan. So let's start with Professor Lim answering this question, if you please.
First of all, actually, in Korea, we have a very strong drive for the hydrogen, actually, but we start to think about how we can get enough hydrogen domestically or internationally. And basically, we are trying to, because in Korea, we cannot produce enough hydrogen used for the whole supply chain of actually Korea. So we are trying to import hydrogen from overseas, like I say, overseas transportation. But thing is that when you get some overseas hydrogen, then how much does it cost? That's number one. But the other thing is that how much CO2 also can be produced from the transportation overseas. So we are thinking about sustainable energy as kind of hydrogen, but at the same time, we also think about hydrogen, clean hydrogen, how you can define it. So basically, we Korea start to have some kind of a hydrogen certificate, showing that clean hydrogen, you should have some CO2 emission less than, for example, a couple of kilograms per kilogram hydrogen. So in, like I say, understanding this kind of trend, I think I have a strong belief that if you just not focus on the hydrogen itself, you should also think about the value chain, overall value chain, because in the previous session, actually, a lot of people share about their kind of a technology advancement in water electrolysis or some kind of a LNG reforming, for example. But thing is that how much CO2 overall can we expect? So we need to think about at the same time. First one is clean hydrogen production, but at the same time coupling with how much CO2 can be produced during the whole process. So now in Korea we start to think about this for the sustainable energy development. So maybe there can be also for the not the domestic level, but international trading as well. So maybe there can be a good opportunity for all of us to have both the domestic and international trading. Yeah, that's what I think.
Yes. Just background information for those who doesn't know. In order to achieve carbon neutrality, it's not enough to only create technologies that don't create carbon dioxide. We already have carbon dioxide in the air, and there will be industries that will still produce it. So carbon capture, that's how they call it, carbon capture and utilization storage, is a very key and important task. And thank you, Professor Lim, for introducing that. And let's move on to Jur, who basically has a different kind of perspective.
Yes, thank you. My name is Jur Immink. I'm from the company Risato High Pressure Technology. We are a Dutch manufacturer of hydrogen high pressure test systems, as well as hydrogen refilling stations. And if we look to the whole energy transition in the Netherlands, we are in a very early stage, I would say. But nevertheless, we are doing quite a good job. So if we look to the domestic overview, we have a lot of solar parks, a lot of wind parks in the Netherlands, as well as very good infrastructure for electric cars. So for instance, last year, more than 30% of the new registered cars in the Netherlands were electric. As well as new built houses. We don't have any gas connection to the gas grid anymore with new houses, and then we need to put solar panels on our new houses. And that you can see we are very busy with the energy transition. However, all this consumption of energy and production of energy has a lot is causing a lot of problems, other challenges for the energy grid. So we have a lot of overcapacity currently in the Netherlands with electricity. So we can use that electricity for making, for instance, hydrogen. And if we look to the perspective from Risato, we can compress hydrogen. So for instance, if you have an electrolyzer, you can produce your hydrogen, and we can compress it to higher pressures, which you can store it in, let's say, in high pressure vessels. And eventually we are making the infrastructure, or we try to make the infrastructure for hydrogen in the Netherlands or in Europe with making our own hydrogen refilling stations. So as you can see on the PowerPoint presentation, this is an overview of the currently installed hydrogen refilling stations in Europe. We have installed more than 50 stations at the moment, and we are convinced that if you want to replace the fossil fuels, there will not be only one solution, there will be multiple solutions, and one of them is hydrogen. And we are expecting to install by 2030 more than 1,000 hydrogen refilling stations in Europe or even globally. And we are convinced that this hydrogen refilling stations will help in the total energy transition.
Thank you. Do you have numbers? How many stations are available in Europe? Or Netherlands, whatever you know.
No, I don't have specifically in numbers, but said we currently have installed 50 already, and we see
you alone. I mean Risato.
Risato, and we see that we have a lot in production right now. So the numbers are expanding quite soon.
Growing market.
Yeah, for sure.
Will it draw the prices lower? Do you think?
It's of course a price-driven market, but you need to be
more than this.
Sorry?
More than this.
Yeah. So we will see where it ends.
Thank you. So let's continue with Christian. What is your opinion?
Yeah, first of all, I would like to thank to be a part of this conversation with such a great partners. And for the question, I think I try to focus on a different object because as I'm a university member, one word what I heard a lot in the last couple of years is the TCO. So I in a lucky position because I don't have to. I have to think about the prices and I have to think about the financial place. But first of all, as an engineer, I can focus on the development and the research. So on the hydrogen technology, I think we are in the same footsteps as we were when the electric cars became common. That's why the education is the most important thing, I think, and also the market to be able to give the enough knowledge to the society. As a university member, I also think that our main mission is to give enough knowledge to the society about the hydrogen technology. And if we look at the past, in 1937, there was a big tragedy. Maybe some people know that it was the Hindenburg tragedy in Germany. It was a German aircraft, a German Zeppelin, where it was burned down because of a technical issue. And in my opinion, only one mistake is enough, and it can be corrected with 1,000 success. So we are on the early road. We are on the first steps in this kind of technology, and maybe with enough education, with enough marketing, we will be able to make the hydrogen technology as common as the EVs. Because nowadays, I think nobody thinks that EV is more dangerous than the version of a combustion engine one car. So our mission, I think it's to make this happen in this field.
Thank you very much. That's really clear explanation. And so let's continue with Achilles, who brought us a thorough slides to answer this question. Should we? Yes.
Gonzer, as a system integrator and manufacturer, takes role of green hydrogen projects, providing hydrogen production and storage technologies and maintenance services. There are 3 industrial-scale green hydrogen projects in Hungary currently. For 2 pilot projects, Aquamarine in Kardoskút and the second in Bükköbrány, the high-quality components manufactured by domestic and foreign suppliers with marked leading extensive industrial experience were supplied and assembled by Gonzer's team here in Hungary. Currently, we can see 3 different applications how end users utilize the green hydrogen in their operation. The first, please the next. The Hungarian Gas Storage Ltd, the MFGT, in frame of Aquamarine project, will mix the green hydrogen into the natural gas. MFGT utilized its Kardoskút-based underground gas storage facility in a research and development project. As part of the ongoing project, an electric and intensifier system will be built. Moreover, hydrogen mixing and dosing technology system will also be developed, to boast the hydrogen mixing and dosing technology. The site total normal capacity with the new technology will be 2.5 megawatt. On the one hand, the produced hydrogen is mixed into natural gas and utilize the Hungarian gas storage capacity with own gas engines and furnaces, reducing the CO2 emissions of the technology. Please, the next. On the other hand, in addition to the direct energy use, as well as the capacity testing of the transmission line and distribution systems, the aim to conduct an industrial scale experiment for the long-term storage of hydrogen in underground gas storage at pressures above 100 bar. In Bükk-Ábrány, please the next. In the Bükk-Ábrány project, it is a unique hydrogen production plant which is directly fed by the PV systems. The R&D project run by Photovoltaic Power Station Projects Ltd. And the University of Szeged utilize solar power to produce hydrogen by PEM electrolysis system. Please, the next. Hydrogen produced by greased energy is planned to be sold in the industrial gas cylinder bundles. And later there is an option to install a fuel cell unit for power generation. The new hydrogen plant of MOL Group will start producing in the second half of the year. It is expected to be the largest green hydrogen plant in the Central and Eastern Europe, set to be operational this year. You can see our other partners in the hydrogen projects, so I'm sure that we, the GANS-Air, have gained that experience in a fairly broad group in the hydrogen industry technology. Thanks.
Thank you. So we got some really detailed information, both international, both domestic, and we can see that basically we all go in the same direction, but of course not on the same scale, because as we could see, South Korea might invest more in hydrogen because they see bigger not challenges, but possible ways to solve their own sustainable energy. Netherlands do the same. Hungary is following the European Union rules. During your work, as you're all affected somehow, did you experience, or what were your experiences, the main problems during your professional work, or based on literature in academy? What do you see that are most key problems that we have to face today and in the near future? Let's start with Rezato. Let's start with you.
So as said, we are a company that's very known and experienced in compressing all kinds of fluids and gases. We started basically 8 to 10 years ago with the development on compression with hydrogen. And what we saw at that time is that if you want to fill up or fuel up your vehicle, you need hydrogen at 350 bar or at 700 bars. So on one side, we made the development for our own hydrogen refilling stations, and therefore we have two type of units that we can supply to the customers. One of them is a small system that can fill up a small scale of hydrogen car fleet, and the other one is basically a hydrogen refilling station for public situations to fill up vehicles from passenger cars up to heavy duty vehicles. So that's on one side solution that we can offer. On the other side, and Christian was already mentioning, the safety for using hydrogen in vehicles is very important, and therefore for instance, the materials that will be used in the vehicles needs to be tested with hydrogen. And one of the objects that are used in the vehicles is a Type 4 pressure vessel. It's a composite pressure vessel, and this vessel needs to be tested as well. On one side you have the homologation testing, and the other side you have the end-of-line testing. So each tank that is produced needs to be tested anyway, either with fluid or with gases. If we look to the solutions that we can offer, it's on the next slide. We have basically a scope of supply for the whole test chain for composite vessel testing. One is the fluid testing. You need to do a 100% end-of-line test with fluids. That needs to be done at 1.5 times the working pressure of the pressure vessel, so it can go up to, let's say, 1050 bar. But you need also to perform a burst test on the tank, and therefore we cannot go up to 2500 bar to do a burst test. For a type of approval test, you need to do hydro cycle testing, and that's the unit in the middle. We can do it on ambient temperature conditions as well as extreme temperature conditions. And that's needed to get an approval on your tank, and that it's safe to use in your vehicle. And at the end, we can do as well hydrogen leak testing or cycle testing with pure hydrogen. So we can do it with, let's say, up to 900 bar. We can compress it up to 900 bar, and we go straight from buffers into the test chambers. And what the main goal for us is to perform safe testing. So we have all related safety features in the systems, so that the operator that's performing the test have a safe environment, and it's sure that there will not be a hazardous situation while you're testing with hydrogen.
Thank you. And Christian, what are your answers for the challenges?
Yeah, firstly, sorry David, but I have to correct you, because as the gentleman mentioned before, we don't have problems, we have challenges for this year. And I think at the last year we are reaching a milestone because we are produced something which you can check at the hall. And if you can take another slide, yes, this one, you can see our first prototype. This is the Neumann H2. Anyone who knows me knows that the green mobility is close to my heart. So to produce something which is works with hydrogen, which works with battery or like a solar panel in this car, you can have them. So it's a complex energy mix. About the simulation, because we have a digital twin of this car, we are calculating that the range in this energy mix is around 250 kilometers, and it has a high pressure vessel. Maybe you can take another slide. Yes, thank you. 350 bar high pressure we have in this vessel, and 5 kilowatt PEM fuel cell used for the powertrain. And we also have a high voltage battery with our own BMS technology, and we are using solar technology also. And as I told you, it's a complex energy mix, so thanks to the artificial intelligence we can provide the best solution for all the situation. And we also use this technology, so the AI, not only for the energy management, but if you go to the other slide, please. You can check it. We have plenty of displays there and plenty of cameras around the car, so we can check the environment around it, and we can recognize the environment, and we can make a emergency brake, for example. So it can be a solution for the green mobility, but I have to tell you that it's only a prototype first. So the challenges for this year, to answer this question, is to make the test around the car, because at the end of the last year it exhibited in the COP28, and we have a lot of experience in this place, and I think in the next year we should make these tests because of the improvement of the car. And we also have another pilot project. Because of the experiment, it will be a Type 5 vessel, pressure vessel, and I think it will be a complex system. Maybe we can say that in Hungary, John von Neumann University tried to lead the way in the hydrogen technology, and this is one of the proof of this these words. Thanks.
Thank you. Oh, sorry, I forgot to check another slide. If you can show. So this is the system you were talking about, the environmental detection. Oh. Yes, so, and now the word goes to Ganzer again, to see what were your challenges, how do you see them? So, Achilles, please. Yes.
We can see a few hydrogen production technology worldwide, but the European Union, Hungary, and also the Ganzer too prefers the PEM solution. The PEM technology has own advantages, flexibility, and it suits perfectly to the renewables. Is the next. We suggest to our customers the IM type for smaller modular systems. Ganzer has started to develop our new 1 megawatt electrolyzer product. Please, the next. We realize the market need, and our goal is to support the development of the domestic and regional hydrogen industries with production base. We are in the design phase, and we are facing some challenges, especially the balance of plant. The energy demand of the whole processes can be reduced depending on the operational functions. Theoretically, the water electrolysis is a well-known from science point of view, but on this industrial scale, it has several challenges. You can see this picture that it isn't a simple machine. It isn't a simple accumulator. It isn't a simple bottle. It is a professional system from the water to the industrial clean hydrogen. And we has a complete engineering team who can checking all point of parameter, because it is an emergency technology if we don't close all open question in the engineering time. You can see our planned first version of the 1 megawatt electrolyzer. It is the design phase, and we know that the elements of this technology can function, and we will in the next year produce and shows for the market a functionable electrolyzer station. And we can support in Hungary and in Europe too the hydrogen utilities. Thank you.
Yes, so it's always easy to see that, oh, hey, I'm selling a product, it's working, and there's a Hungarian saying that's the pudding is always just as good as you can taste it. So finally, when you install such a big machine like an electrolyzer, yeah, problems can come, and that's what Gonzer manages well. So let's continue with Professor Lim. Challenges?
Yeah, so there are many challenges, as you may imagine already, but when I talk about the hydrogen, for example, a lot of people already knew that there are colorful hydrogen, ranging from the gray and blue and even green, maybe green hydrogen from water electrolyzer. And some people also think about say that pink hydrogen from nuclear power plant, or even orange hydrogen. There are so many different kinds of colors. But for the perspective of education, because I'm also the professor in UNIST in South Korea, and I want to focus out that we should have some consensus. What level, boundary, we need to think about when we evaluate the CO2 emission, for example. Like I say, hydrogen production from natural gas or hydrogen production from fossil fuels produce a lot of CO2 emission actually. In that case, maybe we can say that, okay, that's great. But how we can say clean hydrogen? There is not consensus so much like I say last year till, but now we start to have some kind of define, the concept of different colors of hydrogen as well. But it varies depending on the countries now. So we don't have any international solid kind of criteria how we can define the colorful hydrogen now. So now is the right on time for a lot of kind of say countries involved to set the standards, what you call green, blue, or kind of say gray. Next step is, okay, let's go to, we can make some capture system, CO2 capture system, for example. But thing is that we should think about, isn't it really reduce the CO2 emission, or do you produce more hydrogen? That means that carbon positive. So now in this sense, even though I myself working on the CO2 capture system myself, but thing is that requirement getting severe. So they don't want actually more CO2 coming out of my CO2 system. But it's very tough to design like that because we used to build up some kind of a system just like I say showing the good efficiency, showing the good profit out of it. But now another criteria is putting on the design criteria how you can reduce CO2 emission, something like that. So I do focus on that, saying that this is kind of approach is a systematic, not the just unit basis one. Like I say, don't focus only for the electrolyzer. We need to think about where the water comes from it, and then where will you use the green hydrogen, for example. So the issue, there are so many issues I can focus on, but the thing is that step by step, we should think about having the consensus, the defining definition of colorful hydrogen, for example, and then boundary as well. So, and if I add one more talk onto my talk, actually, Koreans, actually, they want to actually start to transfer hydrogen from overseas, different countries. But when you think about it, and CO2 emission from the another country, and also CO2 emission from the transportation, shipping probably, and CO2 emission while processing in South Korea, and who will be responsible for CO2 emission for that? That kind of things, it is not easy thing. So maybe we should overcome those kind of issues to have some more sustainable development in terms of hydrogen as well as the CO2 capture. Yep.
You're right, Professor. I bring you another Hungarian saying that if we don't do as you said, and we don't create those borders and define the parameters correctly, then we just peel up and stand under it, and it will fall on back us. So yes, true. General overview is required. So let's say that here's a wizard cap and I put it on, now I'm a wizard. I have even a wizard stick, a magic stick. What is your wish for the future? How do you, so what is your wish for the future to make your community a step forward towards a sustainable energy? Let's start with, with Christian.
Thank you for the question. I think if you were able to be a wizard,
I am.
Yeah. I ask you something, but not in that field, so not in the hydrogen technology, but it's not. It's a different story. Yeah, maybe I can tell you that as a university member, we can't control to make more refueling station. We can't have enough control to make more electrolyzers and the largest capacity of the hydrogen. But as I told you, we have a mission in education, and this is our first focus. But yeah, maybe if you can make something different for us, I ask you to make our prototype more famous and take it more widely known, because I think as a university it is the only way to catch the people's eye, and it's really important for us. But another alternative is also important, because hydrogen is not the only alternatives in the vehicle or other technologies, because we have also, for example, the solar. And the next year, I think our mission can be in that field. As I told you, if somebody knows me, knows that I'm love these cars and love these prototypes, so I don't take any words, but maybe it can be a solar next year, and we are focusing at that field, because the hydrogen is not the only answer for our questions.
Okay, thank you. What is your wish, Professor Lim?
That's a very good question, by the way. If you are richer, then probably still I'm learning myself, even though I'm the professor, because there are a lot of new technology coming out. For example, AI and machine learning these days. And even though we apply AI machine learning successfully on the battery diagnostics and the prognostic, for example, however, we still need kind of the more knowledge on it, more understanding. But when the problem getting worse is when I apply the kind of machine learning or AI concept into physical phenomena, because I cannot cover all those kind of things. So if I just give me the kind of power to understand all the physical phenomena happening inside, for example, maybe I'm not expert in the electrolyzer, but I'm working on the carbon capture system, for example. And as a Christian say that, we need to think about not the hydrogen is the only option. Maybe there can be one viable option though, but we may also think about maybe if you capture CO2, for example, what if our ultimate goal, for example, and the use? Do we want to use just a CO2 as a dry ice? That's not that attractive, because it's just a physical, dry ice made by liquefaction of CO2. That's very simple. And what if it's attractive then? Maybe we can think about making some, you may already know it, but e-fuel out of a CO2. Then how we can provide actually hydrogen, for example? There are so many things I need to think about, many, actually move over, thinking over and over. But the thing is that I'm still lacking of my knowledge to understand still physical phenomena associated. So that's why, we need kind of strong collaboration between many parties involved, right? So if I have some power to understand physical phenomena, and also beautiful kind of my brain myself, and apply some kind of AI machine learning, that'd be great. And the last word is, I'm the chemical engineers, and we used to build a very huge, like I say, tall story distillation or some kind of absorption tower, very huge one. But not anymore, because it'll be very energy intensive. And then it will emit a lot of CO2 emissions, right? So we need to go to compact and smaller. But as you know it, making smaller compact, looking at your smartphone, now it's very compact and small. But how long did it take from the one big smartphone and then getting to smaller size? It takes about 20 years or so, right? So if you give me the kind of power to see the trend, when this will come out, then that will be also the one of the good option to me as well. Yep. Thank you.
So you have more wishes. I only said one wish. You're like my kids.
Oh yeah.
You can take one ice cream. I want two. So how about you, Jur?
Yeah, well, I'm agreeing on a topic that both gentlemen already mentioned, is that there is not only one solution to start this energy transition. And if I look to the people in probably in my country, a lot of debate is going on that the energy of electric cars haven't that good range. We are not ready for it, and etc. etc. And my really wish is that there is more acceptance that the energy transition is ongoing, and we really need to speed up in this process and accept that we need to change, instead of discussing that it's bad or that we're not open to see the possibilities that are already in the market. So yeah, if I look to the near future, I would say that yeah, we really need to accept that things are changing and that we need to do it very fast.
Good, good. Really good, thank you. And finally, Achilles.
You know, we are in the industry, and based on the experience of the pilot projects, the next step is to start to implement the hydrogen strategy, focusing on some highlighted projects aligned to the circular economy and localization. These potential projects will offer to the market and supplier segments too. From technological point of view, the R&D design, test, and manufacture phase are slipped together. Hopefully, till the end of the first quarter 2025, we will have own functioning electrolyzer with 1 megawatt capacity, and we will be ready for the mass production. This achievement can boost the market and speed up the progress towards the green hydrogen economy. We are sure, and that this way can help for our and for the next generation. In our focus, there are two fixed points. We will have every day more and more sunshine, and we will have a stable electrolyzing technology. And so we can produce in the industry green hydrogen, and so we can give to this and for the next generation a green energy, a green power, and so we'll have a chance, the generation of our children that can be live in a green globe and can walk in a green park, because with this green energy way, we can save the green future for the next generation. It is in our focus. Thank you.
So you wish the new electrolyzer as a product to be in the portfolio and consider an ambitious goal. And okay, so may your wish come true for all of you. I did my job as a wizard. So thank you for creating this very diverse panel, I would say, and I'm really glad that you accepted our invitation, and I hope that all of you had fun, had a good time. We try to make it as casual as possible. So I think I will close this event with just an extra information that we doesn't stop right now as we go out on the door. Let's visit the cars downstairs. We can talk about them personally. I mean, I can also talk about it. Christian also can talk about it. Károly, who brought the car, I don't see you, but you can talk about the Mirai as well. So. And thank you for Toyota for also participating in this as a presenter of the Mirai, and thank you, Károly, for bringing it here. So anyway, thank you again for you that you came. I hope to see you on the 4th hydrogen workshop. It will be our pleasure to announce it when the time has come. and have a nice time for the rest of your day. Thank you again. Bye.